Okay, now Ali Habib has a slightly different solution. Okay, this is whose solution? This was Muhammad Ali Al-Ghamdi's solution. But Ali Habib, he says something else. Okay, we could have changed this. We could have said something like this, where x is larger than 1 megabyte. So then the solution just changes to this. Here you have two parameters. So it is not really necessary. So you can put that extra parameter and then say if x is larger than 1 megabyte, or you could have just said this y, and x is larger than x is a message, and it is larger, y is greater than 1. So you could have made it, yeah, you could have made it, no, this 1 is enough. Okay, so this is what is used on the slide, the first statement. So they've used L for this instead of M. They have used L, and for C they have used C. So that's the only change. So it depends on how you want to write it. Okay, so both the solutions are okay. So now let's look at the next statement. If a user is active, if a user is active, at least one network link will be available. Okay, this is a slightly tricky one, so we'll have to write. Now, if user is active, at least one network link will be available. Now, the first thing is coming up with variables. You need to come up with variables. So you can say user is active, and then network link available. Okay, so we can write, let's say user is active. So this means user U is active. Network link will be available. So how will you say this? Network link will be available. N is available. Okay, so these are two things. So A of U is active, and N of N network N is available. So no, Muhammad Ali, you have to understand that user is different and network is different. You cannot not use the same variables inside. If you use X, that means X is a user and X is a network. That's pretty difficult. Okay, you have to use different variables. Okay, so if I say A of X and N of X, X and user cannot be a network and the same thing. So you use some different variables. Yeah, K is okay. X and K is okay. Very good. Okay, if a user is active, then at least one network link is available. So you have if and then. Okay, so if something, then something. So we know there is a arrow in between. So if a user is active, if a user is, at least one user is active. So we have at least user who is active. Then at least one network link is available. Then at least one network link is available. Okay, Muhammad Ali, if a user means some user, all not X, all. X. Is that clear? So you have to break it up slowly. I know many of you are getting confused. So this requires practice. It's not something that you can, there is no rule over here. You have to make mistakes and then try your solution out. But here we are not saying all users. Okay, Muhammad Ali, we are not saying all users are active. We're saying if a user is active. If a user is active. Uh, I'm not sure. I don't think it appears. Muhammad Ali, you're saying for all x, the sum x. It may be right, it may be wrong, but that's a more complicated solution. This is a direct translation. So here I have, if you look carefully, you have if something, then something. So the if something is on the left, then something on the right. Okay, so if a user is active, yeah, I can explain it again. So let's wipe out everything and do it again. Okay, if then. Okay, so if a user is active, then at least one network link will be available. Is this statement clear? Now I want to translate this into, so I have something here, then something here. Okay, so I have A, statement A, statement B. So can I translate that to this? Is this right? Is this clear? Okay. We've done this long back. We know this. If something, then something, it translates it into this. Now let's go back to that. If a user is active, if a user is active. So we're saying a user is active. Does it mean all users or some users? If a user is active. So it is some. So this is for some users. User U is active. Okay, is that clear? A is active, but not all users, only some. So A. So we write it over here. So we have some users who are active. Okay, then what happens? Then at least one network link is available. So if I say this one, so n of k is available. Okay, network link k is available. So the statement says at least one, also some, at least one link is available. Yeah. So now I just put it there. That's all. That's it. Did you get it, Firas? Muhammad Ali? Okay, so all you need to do is break it up, break it up. I know this is something that will not come immediately. It just requires practice. We will be looking at examples after this which are very confusing. So all we have to do is break it up as small pieces and then try to analyze it. This comes with practice. It is not a rule. I cannot say step one do this, step two do this. It is just every statement is English statement is different. It takes different experience. Let's look at slide 38. Okay, only look at slide. Only look at number one. All lions are fierce. Only look at the first statement. All lines of slide 37. Yes. Okay. Don't worry about premise and conclusion and all that. We will look at all that later. Today we'll just look at translating from English to this. Uh, No, Muhammad Ali, 37 is the Lewis Carroll example. Slide 37 is the Lewis Carroll example. Do you see that example? Or do you see something else in the slides? All lions are fierce, some lions do not drink coffee. Do you see that on your slide 37, or you see something? File number 2, logic proofs. Okay, it's okay. Don't worry if you don't see it. So statement 1 is all lions are fierce. How will you translate this? All students have taken Java. Yeah, thank you very much, Ali Habib. You typed out the entire thing. So statement number 1, all lions are fierce. All students have taken in this class have taken Java. All students have visited Mexico. So all is we have this, and because we are connecting two different things, lion is fierce, and X is a lion, and X is fierce. Okay, so we have if X is a lion, then X is fierce. Okay, if X is a lion, then X is fierce, and this is true for all. Okay, so what if some lions are fierce? How will you translate some lions are fierce? It's not on the slide. Some lions are fierce. How will you translate this? Very good, Muhammad Ali. Anyone else? So for some lions, so we need this and this, and so we need and. Very good, Ali Habib. So some lions are fierce. Okay, this is some lions are fierce. Okay, the next statement, some lions do not drink coffee. Some lions do not drink coffee. How will you write this? Some lions do not drink. So for some you need for some, then you are connecting two things, so you need an and. So some lions, that is if X is a lion and do not drink coffee. X does not drink coffee. Does not C of X is does not drink coffee. So that's all. Okay, there is a pattern. When you start solving it, you will see a pattern. Yes, Sultan, that's the correct answer. Firas has used, he's not used, he's used, see if he's used this, Firas has used D, so probably it means X does not drink coffee. Is that right, Firas? Yeah, so he's used dx as does not drink coffee, so his solution is and d of x. He does not use the not symbol. He's not using the not symbol because d of x means x does not drink coffee. And Sultan has used c of x and Muhammad Ali also as drinks coffee. So that's why they have put the not in the front. So both the solutions are right. Muhammad Ali and Sultan, they have used C of X as drinks coffee. So that's why they're putting the not in the front. And Firas has used D of X as does not drink coffee. So it does not use the not symbol. So very good. Both are right. Okay. So let's look at the third statement. The third statement, some fierce creatures. Some fierce creatures do not drink coffee. Do not drink coffee. I think this is very simple now. Some fierce creatures do not drink coffee. Yeah. Okay, this is simple. So some, we have some, and you have and. Very good. So fierce creatures and do not drink coffee. So this is okay for those who are, yeah, very good, Sultan. Okay, and Muhammad Ali also. Okay, so those who have solved today, don't you think now it's becoming easier after we have taken a few examples? It gets easy. We've seen the pattern and immediately you can translate it. Okay, so this is with practice. So it's good. Those who made mistakes today, very good, because when you make mistakes, you're trying, and when you try, you will be able to understand it better. Okay, so this requires practice. So there are lots of yeah, Muhammad Ali, very good. So he's used C of X as do not drink coffee, just like for us, and he's not put a not there. So this is also okay. So it's up to you, but it's important that you define what is C of X and F of X before you translate it. Okay, so we will stop with this for now. And for those who are had a problem understanding today's lecture, please watch it again and try. The only way you will understand this is by trying. The more you try, the more you make the more mistakes you make, you will be get more confident. So this does not happen immediately. You cannot just start translating it into logic. You'll have to work out a pattern and then it becomes simpler. So we will not give you very complicated statements in the exam to translate. Very simple things like most of you will be able to do. Okay, but it requires practice. Please work out all the things that are given in the tutorial. How are your tutorials going with Mr. Khalid Al Malki? Very good. He's mashallah very good. Okay, try to take advantage. He may be tough, but he's very good. So please try to work out all the examples that he's giving, and there are examples in the textbook also. So please try to work out those examples to get more confidence. So when you see a question like this in the exam, it is a very simple question that you're able to solve. Okay, so with this we stop for today. Inshallah, from the next class we look at nested quantifiers. Okay, so I'll be stopping this recording. Assalamu alaikum wa rahmatullahi wa barakatuh.